What if I told you there's a bear so tiny it can survive some of the most extreme conditions on Earth? Would you believe me? Meet the incredible tardigrade. Okay, let's discuss it in more detail.
Scientists have tried to kill it with everything they have. Boiling water, freezing temperatures 200 degrees below zero, radiation doses 1,000 times lethal to humans, the crushing pressure of the deepest ocean, the vacuum of outer space. Every time, it survives. It is less than 1 millimeter long. It has no brain to speak of. It has been on this planet for 500 million years, and it is, without question, the toughest living thing that has ever existed. The tardigrade, also known as the water bear or moss piglet, lives everywhere, not in a few specific environments the way most extremophiles do, everywhere. It has been found in the highest peaks of the Himalayas and the deepest trenches of the Pacific, in hot springs in Iceland and in Antarctic ice sheets, in rainforest canopy and in urban gutters, in your backyard, almost certainly right now, living in the thin film of water that coats every patch of moss and lichen within 100 meters of wherever you're standing. There are over 1,300 known species of tardigrade. They have been on Earth since the Cambrian period, 500 million years ago, predating the dinosaurs by nearly 300 million years, surviving every mass extinction event the planet has ever thrown at complex animal life. The asteroid that ended the dinosaurs? Tardigrades were fine. The Permian extinction that wiped out 96% of all marine species? Tardigrades were fine. For most of scientific history, this was treated as a curiosity, a footnote in biology textbooks, something children found delightful and professors found mildly interesting. Then, someone decided to find out exactly how it was surviving. What they discovered rewrited the boundaries of what biology considers possible. The tardigrade's survival mechanism is not what most people assume. It is not that the animal is somehow tougher than other creatures, thicker skin, stronger cells, more robust proteins. It is that when conditions become lethal, the tardigrade enters a state called cryptobiosis. It pulls all the water out of its body, retracts its limbs, and curls into a microscopic barrel called a ton. In this state, its metabolism drops to less than 0.01% of normal. Its heartbeat stops. Its breathing stops. Every biochemical process that defines life by any conventional measure ceases. And yet, it is not dead. Inside the ton, something remarkable happens at the molecular level. The tardigrade produces massive quantities of a sugar called trehalose, which forms a glass-like matrix around every protein, every cell membrane, every strand of DNA in its body. This glass holds all of the tardigrade's cellular architecture in suspended animation, perfectly preserved, perfectly intact, for as long as necessary. Decades, in documented cases, over 30 years. When water returns, the glass dissolves, metabolism resumes, and the animal walks away as if nothing happened. It is not survival, it is pause. Here is the question that keeps philosophers and biologists arguing in the same room, which is rare and usually productive. Is a tardigrade in cryptobiosis alive? By every measurable biological standard, no. There's no metabolism, no cellular activity, no response to stimuli. If you applied the clinical definition of death to a tardigrade in the ton state, it would be classified as dead. Every test would confirm it. And yet, given water, it returns completely, without damage, without memory loss, because it doesn't have enough of a nervous system to have memories in a conventional sense, but all of its behavioral patterns resume perfectly. This is not resuscitation. Resuscitation implies the processes were merely suppressed. In the tardigrade, they were absent. The question of whether it was alive during that interval is genuinely unresolved, not because we lack data, but because the tardigrade exists in a category that our definitions of life were not built to accommodate. In 2007, the European Space Agency sent tardigrades into low Earth orbit, exposed, unshielded to the full vacuum and radiation of open space for 10 days. When they were brought back and rehydrated, 68% survived. Some subsequently reproduced successfully. No other animal has ever survived unprotected exposure to open space, not even close. The implications of the tardigrade's survival mechanism, once researchers began to fully understand it, reached immediately into some of the most pressing problems in modern medicine. Organ transplantation is currently limited by one brutal constraint. A donated organ can survive outside the human body for only 4 to 6 hours under the best preservation conditions available. Every year, thousands of viable organs are discarded because they cannot reach a recipient in time. Thousands of patients die on waiting lists for organs that existed briefly and then became unusable. The tardigrade's trellulose-based preservation mechanism is now the leading candidate for solving this problem. Research teams at multiple institutions are working to develop trellulose-based organ preservation solutions that could extend viable preservation time from hours to days or longer. Early results are promising enough that the U.S. Defense Advanced Research Projects Agency, DARPA, has funded research into using tardigrade-inspired preservation for battlefield blood transfusion supplies that require no refrigeration. And in space travel, the tardigrade is reframing what long-duration human spaceflight might look like. The fundamental obstacle to sending humans beyond Mars is time. Years of continuous radiation exposure, muscle atrophy, bone loss, and psychological deterioration. A metabolic pause, a controlled cryptobiosis-inspired state that dramatically slows human physiology during transit, is no longer science fiction. It is an active area of NASA-funded research, informed directly by the biology of an animal that figured it out 500 million years ago. The unkillable, it turns out, is also the key to making humans less killable. There's something unexpectedly moving about the tardigrade when you sit with it long enough. Not because it is beautiful, though under a microscope, in its slow, ambling way, it has a kind of charm. Not because it is powerful, it has no venom, no armor, no speed, no size. It cannot fight anything. It cannot outrun anything. It survives by doing something that seems, at first, like weakness. It lets go. When the world becomes unlivable, the tardigrade does not fight the conditions. It does not adapt in the moment. It does not harden itself against the cold or the heat or the radiation. It simply releases every process that requires the world to be survivable and waits, without anxiety, without resistance, without any biological mechanism that corresponds to suffering. And when the world becomes livable again, it resumes exactly where it left off, unchanged, undamaged, ready. 500 million years of survival, not by being the strongest, by being the most willing to stop and trust that the world would eventually be worth returning to. There is no animal on Earth that has been more patient. If this episode made you think differently about what it means to be resilient, share it with someone who needs to hear that surviving sometimes means letting go. Next episode, we follow one of the greatest journeys in the natural world, the salmon that swims thousands of miles back to the exact stream where it was born, guided by a magnetic map, a chemical memory, and a drive that ends with its last breath. How does an animal find its way home across an entire ocean? Stay curious.